of Leetcode daily challenge of this month, and it is late, and I apologize for that. The reason for that is I've been traveling the whole day. I didn't have an access to internet nor uh, a good environment where I could open my laptop. Due to that, it has been late, and there's just about 2 hours left before I can complete this challenge. So I rushed back to my room after the traveling. I didn't even wash my hands because I'm keen to complete this question today. So let's get back to it. Hope it's an easy problem. Because I'm very sleepy and I'm very dizzy after all the travel. Uh, it's a hard problem. Okay, there's nothing I can do except to solve it. So let us quickly go through the question. So we are given, what is this? We are given some plants, and each plant has a plant time and a grow time. And first we need to plant it. Once we plant, it takes plant time of I days before it starts growing. And on a single day I can only plant a single plant. Okay. Mm-hmm. The question is so confusing. I don't know, either the question is very confusing or my mind is not working right now. Looking at the likes, I think it's my mind which is at fault. I don't understand the question anymore. So we need to create a permutation of we need to find a permutation of an order of planting these plants such that all of them blossom in the minimum time, something like that, right? uh, I don't know, but it seems a little intuitive, a little, that you see, I'm not even sure what the question means, but question is, but looking at the diagram, I can conclude one thing, that on a single day you can only, these gray pots, I think it is the planting time. So on a single day you can only plant one single plant. Like you can't have two gray pots on the same column, something like this. Okay, but you can mix up these grape plants with this orange plants. Like you can plant a new plant when an older plant is already growing. Yeah, something like that. And growing is something which you don't have any control over. So once the planting time of a plant is over, it will keep on growing without our consciousness. So these orange things, they're permanent, but these gray things, these aren't. We can choose them. So I think the best optimal solution for this would be choosing a permutation in which most of these gray pots, I mean most of these planting days, they are shadowed by these growing days. Like, so if you see here, these three planting days are being shadowed by these three growing days. So due to this, we saved a lot of time because we're doing you know parallel work at the same time. But for this, we can't find something to shadow, so this will hurt us, something like this. So I guess we should start with the plant that has the maximum growth time, because as it keeps growing, we can keep on planting other plants. think that makes sense. But if two plants have the same growth time, in that case, I guess we should choose a plant that has less plant time, because we need to minimize the time it takes to plant, something like that. I don't know. Let me try that. I would use a heap for that. Let me take a heap, and for plant time and grow time of each and every plant. I'm sorry if I'm not able to explain what I'm doing right now, because I'm really tired, and uh, I don't know, I'm feeling a lot dizzy. I've been traveling the whole day, so please excuse me if I can't explain it good. So simply saying, what I'm doing is I'm taking each and every plant and I'm putting them in a heap, such that I choose to plant the plant with the highest growth time, highest grow time first. So I would sort I would put my plants into the heap with these attributes like negative grow time, because because in Python this is a min heap, so I need to put negative sign to convert this to a max heap in terms of grow time, and sorry, g time, and max and a minimum and a min heap in terms of p time, because we need the plant with the minimum p time first. And then I think I'm not sure if this would work, but I mean, given the constraints 10 power 5, we can't go with the DP solution or a recursive solution or anything like that. So it has to be a greedy solution. Though I'm not able to prove if it's a greedy solution or not, and I don't even think I have any capacity left to prove. So if greedy doesn't work, I'm just going to copy the solution and paste it, because I'm exhausted. Apart from that, okay. So I'll go through all the elements in my heap. So current p time, comma current. I've put them in this order of growth time and plant time. So current growth time and current plant time is equals to, I'll pop the element, and then I've put a negative sign here, so I'll just remove that. Okay, so let's say, so this planting time, it is something we need to do for sure. I mean, the time that has already been that's already behind. I don't know how to explain this, but let me have a variable for time. So the time it takes to plant this current plant is current p time. Now you might think that it would take growing time to it would take current it would take current planting time plus current growing time for this particular plant. But actually, as we can do some parallel work here, right? So maybe we already have some time. Like here, see, if like just consider this example. So here we have grow time of, for the first plant we have grow time of 3 and plant time of 1. So okay, consider 0 indexing, we have grow time of 0, 1 and 3. So in this case, so we can do we can do parallel work on this stuff, right? So this is something we do for sure, and the other thing we can do parallel work. So we could so the current plant time plus grow time would either exceed the already old time, or it won't. So we could do that. So current the time taken, the grow time, we can either exceed it with the, I'm not able to explain it, but this should work. What? Why? Okay, this is this solution is accepted, but I'm not able to see the runtime and memory. No, why? Let me refresh it. This is a bug in the new UI. Okay, it's pretty bad. But yeah, so I'm sorry I was not able to explain my approach today, but I promise you that tomorrow, once I get enough rest, I'm going to remake this video and remake this problem, and in that I'll explain what I did here. Until then, bye. I'm sorry, I'm really exhausted.